Good morning. Happy Monday to you. Welcome back to geometry. If you recall, before the break, we started talking about chapter 10, which is 2D figures. All right, we were finding the area of polygons. So today we're going to do a quick review just to refresh your memory, get you back in the geometry mode before we start in on the next section. All right, so today we are going to review the area of triangles and quadrilaterals. Okay, so let's start off with the triangle first. So if you recall, the equation for area of a triangle is 1/2 the base times the height. Okay, so what does that mean? Well, let's say we have a triangle. Okay, and the base, remember, can be any side of that triangle. Okay, it doesn't matter which one you choose. All right, but based on which base you're using, your height will be the perpendicular distance from that base to the opposite vertex. Okay, so for example, if let's say I want to choose this side as my base, then I need to go perpendicular to that side to the opposite vertex. And so that would be my height. Okay. So let's say, for example, in this case, B is equal to 6, and my height is equal to 5. Okay, so I want to find the area of that triangle. I'm going to simply plug it into my area equation. So area equals 1/2 times the base, which is 6, and the height, which is 5. Okay, so I'm going to multiply those together. So 1/2 times 6 is 3, and then 3 times 5 is 15. Okay, and then don't forget, when we're finding area, we're talking about square units because we're doing units times units. So in this case, we'll just say 15 units squared, or square units. Okay, so that's the area of a triangle. Okay, now if it's a right triangle, all right, if you recall, that is a little easier because we don't really have to find the height as long as we know the length of our two legs. So if we have a right triangle, and let's say that this is our base, then the height is going to be the segment that's perpendicular from that base to the opposite vertex. Well, in this case, that happens to be the other leg. Okay, so for a right triangle, to find the area, we're simply going to do 1/2 leg times leg. All right, so you don't have to find that perpendicular distance, but you may have to use, say, Pythagorean theorem or some other method to find the other leg, so that way you can multiply those two together. So find an area of a right triangle, multiply the legs together, and then divide by 2. So lastly, when we're talking about triangles, you may have an obtuse triangle. All right, so something that maybe looks like this. All right, and so remember, we're still talking perpendicular height. So we need to make sure that we are going perpendicular to the opposite vertex from the base. So let's say, for example, this is our base, okay? And we want to find the height. So the height is going to be perpendicular from that base. Well, since I can't go perpendicular to the vertex because it's out here, remember I need to extend that side out until I can go perpendicular to that vertex, and then that distance will be considered your height. Okay, so make sure that you pay attention to whether or not it's an acute, a right, or an obtuse triangle, because finding the height will be different for each one. All right, so let's move on to finding the area of quadrilaterals, and we'll start off with the most simple example, and that would be a parallelogram. All right, so if we have a parallelogram, finding the area of that is pretty simple. Okay, it's going to be similar to a rectangle, which is length times width, but for a parallelogram, we're just talking base times height. Okay, so remember, the base can be any side. Okay, so if I want to choose this base here, then I need to go perpendicular to that base to the opposite side. All right, it doesn't have to be to the vertex, it just has to be perpendicular. And since it's a parallelogram, it's going to be perpendicular to both opposite sides. So anywhere on there, as long as I go perpendicular from that base to the opposite base, then that's going to be my height. Okay. Now I could also have the height out here if I wanted to. All right, but just make sure that it's always perpendicular to the base that you choose. Okay, so let's take a look at an example of that. So let's say that I've got a parallelogram over here. Okay, and let's say that the length of this side is equal to 6. Okay, and then it's telling me that the length of this side over here is 5. Okay, so I didn't draw that very well. All right, obviously it's supposed to be parallel. Let's try that again. A little rusty after taking 2 weeks off. There we go, much better. Okay, so the length of that side is 5. Now, because that's the side and it's slanted, it's not perpendicular to this base of 6, that is not your height. Okay. So your height, remember, it has to be perpendicular to that base. So if we extend this out and form a little right triangle here, all right, and let's say that this piece that we extended out has the length of 3, okay? So now we need to find the height. Remember, that's this segment right there, all right? And so now we need to find that. So how are we going to find this height? We're going to use our right triangle, Pythagorean theorem. This side is now the hypotenuse of that triangle, and then this section is one of the legs, so the height is the other leg. All right, so a squared plus b squared equals c squared. When we calculate that out, this ends up having a value of 4. All right, now I have my height, and I want to find the area of this quadrilateral, all right, which is just simply base times height. Okay, no 1/2 here, just base times height. All right, so if I want to plug in those values, the base in this case is equal to 6, and we just discovered that the height has a value of 4. So 6 times 4, the area of this parallelogram is equal to 24. All right, so the next quadrilateral we're going to talk about is a trapezoid, okay? So remember what defines a trapezoid. It is a 4-sided figure or a quadrilateral that has exactly one set of parallel sides, okay? So the other 2 sides that are not parallel, those are known as the legs, and then the parallel sides are known as the bases, all right? So we're going to call this base 1, and we're going to call this base 2, okay? So to find the area of a trapezoid, all right, the equation, if you recall, is 1/2 times the height, all right? So remember, the height is still just the perpendicular distance between the 2 bases, okay? So that would be considered our height, and then we're going to multiply that times the sum of the 2 bases. Okay, so I'm going to take the value of base 1 and I'm going to add it to the value of base 2. Okay, so this is in parentheses. Why? Because we want to make sure that we do that first before we multiply it by 1/2 and by the height. So add the bases together, then whatever that value is, multiply it times the height, and then multiply it times 1/2 or divide by 2. Okay, so let's do a quick example of that. So if, let's say that your height is equal to 3, and our bases are equal to 4 and 6. All right, we're going to plug that into our equation and solve for the area. So area equals 1/2 times our height, which is 3, times the sum of our bases. Base 1 is 4, and base 2 is 6. Okay, so I'm going to add the bases together first, then multiply it by 3, and then by 1/2. All right, so 4 plus 6 is 10. Okay, And then I can multiply them in any order at that point, right? I can multiply it by 3, or I can multiply it by 1/2, doesn't matter. So 10 times 3 is 30, times 1/2 is equal to 15, all right? Or I could say 10 times 1/2 is 5, and then 5 times 3 is also 15. So again, once you add those two together, you can multiply with the others in any order, and you should still get the same answer. Okay, so that's area of a trapezoid. All right, so the last two quadrilaterals that we're going to talk about today are the rhombus and the kite. All right, so if you remember, rhombus is simply a quadrilateral that has 4 congruent sides. Okay, and they may or may not have right angles. All right, but all 4 sides are congruent. Okay, and then a kite, all right, is defined as a quadrilateral with 2 sets of consecutive sides congruent. All right, and then, so these two would be congruent, those two would be congruent, and then 1 set of opposite congruent angles there. Okay, so that would be our rhombus and our kite. Okay, so the equation to find the area of both of these is the same. All right, but instead of basing it on height and base, this is going to be determined by the length of their diagonals. All right, so remember, a diagonal is simply a segment connecting opposite vertices. All right, so in this case for a rhombus, the diagonal would be there and there. All right, and then for a kite, they would be there and there. So those are your diagonals there. All right, so in order to find the area of either one of these, all right, we're going to do 1/2 times the length of their 2 diagonals multiplied together. So we're going to multiply their 2 diagonals together and then multiply it by 1/2 or divide by 2. All right, so a couple of things that are going to obviously help you along the way. Make sure that you remember that on a kite, our diagonals are going to always be perpendicular. Okay, and on a rhombus, all right, they are always going to bisect each other. Okay, so those two will be the same, and then those two will be the same. So sometimes that'll help you determine the length of your diagonals based on whatever information that they give you. All right, so once you determine the length of each diagonal, multiply them together, and then either multiply by 1/2 or divide by 2. All right, so if you want to go in the PowerPoint under section 10.1, and there's a couple examples in there on how to find the area of each one of these quadrilaterals and of triangles as well that you can review as well. Okay, so tomorrow we'll talk about section 10.2. Please go in and make sure that you take a look at the PowerPoint notes and familiarize yourself with some of the equations and the terms that we'll be talking about. All right, thanks for watching and have a great day.